Okay, so now let's look at those multiple choice questions. First one, use the graph of function fx to locate the local extrema and identify the intervals where the function is concave up and concave down, right? So apparently, for this problem, the it should be pretty straightforward that the local minimum, it happens at x equals 3, right? And local maximum happens at x equals negative 3. Okay, so for that you see local mean 3, local max, right? So b is gone, right? And then also as you can see that about concavity, so basically it's from 0 to infinity, it's all concave up, right? And then from negative infinity to 0, it's all concave down, right? Concave down. So if you look at those selections here, you realize that the answer should be D. Okay, so that's pretty easy. Number 2. So the graph below shows the first and second derivative of the given function. Select the possible graph that passes through the point P, right? Point P. Okay, so what we can tell? Well, this is the first derivative, right? So you can see that from negative infinity to a negative number, it goes up because it's increasing, and from negative number to a positive number, those are symmetric, right? So it's decreasing. So from here it's increasing, from here it's decreasing, and from this point to infinity it's increasing again. Okay, and also as you can see that from negative infinity to 0, so it's a concave down, right? Because second derivative less than 0, and from 0 to positive infinity, so it's a concave up. Okay, so that's the what we can tell from those problems. And then let's see. So as you can see that, so those are the graphs. Okay, so this is graph A, and apparently it's wrong, right? Remember the first derivative is something like this, right? That's the first derivative. Second derivative, right? So it should be increasing, decreasing, and then increasing. So you can see that part A cannot be true because it's only decreasing and increasing. Okay, so that's definitely wrong. So again, this shows it's increase, decrease, increase. So the train, you see, guys, for C and a D, it's definitely it is wrong because I need an increase first, decrease, and then increase. So B becomes the only solution, right? And apparently you can see that it is increasing, right? Then decreasing and then increasing. Okay, so satisfy this. And also about the concavity, is concave down? Good. I think concave up. So okay, that's number 2. Similarly for number 3, same problem. Okay, so you see the first derivative is here. So as you can see that it's decreasing first, right? And then increasing, and then decreasing, right? So because derivative less than 0, decreasing, derivatives greater than 0, increasing. Same thing for this one. And for the second derivative, so this second derivative less than 0, so it's concave down, right? And this part is becomes into concave up. Okay, concave up. So that's what we can tell. So the trend is decreasing, increasing, decreasing first. Okay. So let's take a look. So you can see graph A. It cannot be true. Why? Because the trend for this function is decreasing all the time. So it's wrong. Okay. And let's see, B. So it's decreasing, then increasing, then decreasing, right? And then concave. But for this part, you can see that this is concave up, this is concave down. Remember, we need a concave down first, and then concave up, right? So let's take a look. So number D, it cannot be true, right? So let's look at C. So it's increasing, decreasing, and then increasing, right? So so increase, decrease, increase. Let's go back to here. But it cannot be true because it's it cannot be true because the graph for the first derivative, it's decreasing, increasing, and then decreasing, right? So this one should be also wrong. So the answer for this one, based on the first derivative test, it should be B. But apparently, guys, problem 3, I think it should have some questions. Why? Because problem 3, I think maybe this is an there is an error with the second derivative. Why? Because the second derivative, as you can see, that it's concave down, right, first, and then concave up. But if you look at our selection, problem 3, the answer is B here. So for here, it is concave up and it's concave down. So I believe for this problem, the correct graph for the second derivative should be in this way, not in this. Okay, that's number 3. Okay, so let's keep going to number 4 and the following. So number 4, the using the L'Hopital rule to figure out, to evaluate this limit. So if you plug in, you will see that on the top, it can give you 0. On the bottom, it will also give you 0. So the indeterminate form, it's 0 over 0 time. So based on the L'Hopital rule, so this limit equals to the derivative of the top, that is 2x minus 7 over 1, right? Over 1. So it turns out you have, it's 2x minus 7. So if you plug in, the answer should give us it's negative 3. Okay, so that's A. There is no problem for this one. Number 5. So for limit of this is infinity minus infinity type. So for this types of questions here, you see it's infinity minus infinity. What we would like to do is to convert it, the problem, and then to a fraction form, and then apply the L'Hopital rule. Okay, so what should we do? Well, one of the things you can think of here is there is a radical getting involved here, right? And then minus x. So a good, well, maybe let me use a new picture to write down the details. So this is number 5. Okay. This limit as x approaches infinity. Square root of x squared plus 6x minus x. Okay, minus x. And you will see that the so the technique we will use for this problem is called conjugate, right? So this is what the technique we would like to use. We would like to let it multiply its conjugate over its conjugate. Okay. And this is a common technique when we